Hello everyone, my name is Priyanka. Welcome to my math classes. I'm teaching full syllabus of class 8 math and we are on chapter number 3, Understanding Quadrilaterals. And today we are going to solve exercise 3.2 of NCERT. In the previous class, we discussed the topic of exterior and interior angles of the polygon. And exercise 3.2 is based on that topic only. So let's solve the questions together. So the first question of the exercise is find x in the following figures. And the figure number A is a triangle. So what is x over here? X is an external angle. So in this figure, we have given the three external angles and we have given the value of two angles and we have to find the value of third angle, which is denoted by x. So how we are going to solve this question? We are going to apply the property of sum of exterior angles of a polygon. So, what does the property say? That sum of all exterior angles of a polygon is always equal to, yes, the sum is always equal to, yes, 360 degree. So, the given figure is polygon and it is a triangle. So there are three exterior angles and we have given the measure of two angles and we have to find the third angle. So we will apply the property that sum of all exterior angles of a polygon is always equal to 360 degree. So that means sum of these three angles will be equal to 360 degree. First angle is 125 degree. Second angle is also 125 degree. And third angle is x, which we have to find out. And the sum is equal to 360 degree. So this is the equation. And from this equation, we can find out the value of x. Now 125 plus 125 is 250 plus x is equal to 360. The value of x comes out to be equal to 360 minus 250 and 360 minus 250 is equal to 110. So the measure of angle x is 110 degree. This is the part B of first question, that find out the value of x in given figure. So this given figure is a pentagon because it is having 5 sides. And x is the exterior angle of this pentagon and we have to find the value of x. So, in the pentagon there are 5 exterior angles and we have given the value of other 4 angles. The first is 70, second angle is 90 degree, third angle is 60 degree, fourth angle is 90 degree and the fifth angle is x. So, which we have to find out. So in this pentagon, we have given the value of 4 angles and we have to find the value of fifth exterior angle. So we know that sum of all angles of a polygon, sum of all exterior angles of a polygon is always equal to 360 degree. So this is a pentagon. So there are 5 exterior angles. So sum of all 5 angles is equal to 360 degree. So we know the value of other 4 angles. So we can find out the value of x. So when we put the value of all angles, the first is 70. The second one is 90. The third angle is 60. The fourth angle which is given to us is 90. And the fifth one is x, whose value we need to find out. And this is equal to 360. So we can find out the value of x. Now 70 plus 90 plus 60 plus 90. So when we add up all these together, so we get the value 310 plus x is equal to 360. So value of x comes out to be equal to 360 minus 310. So which is equal to 50. So the fifth angle of this pentagon is equal to 50 degree. The second question of exercise is find the value of each exterior angle of regular polygon of 9 sides and of 15 sides. So first of all, we know that sum of all exterior angles of a polygon is always equal to 360 degree. So sum of all exterior angles is always equal to 360 degree. So now if the polygon is a regular polygon means all the sides and all interior angles of polygon are same. That means all the exterior angles are also same. So if the all exterior angles of polygon are same, then the value of each exterior angle becomes equal to 360 divided by n, where n is the number of sides of a polygon. So if the polygon is a regular polygon, then all exterior angles will be same. Then the measure of each angle will be equal to 360 divided by n. So now our question is, we have to find the exterior angle of polygon having 9 sides. So if in a polygon is having 9 sides, then the value of its exterior angle is equal to 360 divided by number of sides are 9. So the measure of each exterior angle of a polygon having 9 sides is equal to 360 divided by 9, which comes out to be equal to 40 degree. So for a polygon having 9 sides, the value of each exterior angle is equal to 40 degree. And the second part is for the polygon having 15 sides. So the value of each exterior angle for the polygon having 15 sides is equal to 360 divided by 15, because the number of sides are 15. And this comes out to be equal to 24. So for the polygon which is having 15 sides, the value of each exterior angle is equal to 24 degree. The third question of the exercise is, how many sides does a regular polygon have if the measure of an exterior angle is 24 degree? So in this question, we have given that the measure of each exterior angle of a regular polygon is 24 degree and we have to find the number of sides. So for the regular polygon, we know that each exterior angle is equal to 360 divided by number of sides. So if we interchange these two terms, then the formula becomes number of sides of a regular polygon is equal to 360 divided by each exterior angle. So we can put the value of exterior angle over here, which we have given. So we can find out the number of sides. The number of sides, we can take it as n. So let us suppose the polygon is having n number of sides and all exterior angles are same. Therefore, number of sides is equal to 360 divided by the value of each exterior angle, which is given to us, is equal to 24. So the value of n comes out to be equal to 15. So the number of sides of a polygon having exterior angle 24 is equal to 15. The fourth question of the exercise is, how many sides does a regular polygon have if each of its exterior angle is 165 degree? So now we have given the value of each interior angle 165 degree and we have to find the number of sides of a regular polygon. We can solve these questions by two methods. The first method is that the sum of interior angle and exterior angle is always equal to 180 degree, because exterior angle and interior angles always make a linear pair, because exterior angle is always made on the extended side of a polygon. So the sum of interior angle and exterior angle is always equal to 180 degree. Now we have given the value of interior angle. So we can find out the exterior angle. So exterior angle becomes equal to 180 degree minus interior angle. And interior angle is given to us is 165. So exterior angle becomes equal to 15 degree. So the measure of each exterior angle is 15. So now we can find out the number of sides. Number of sides of a regular polygon is equal to 360 divided by each exterior angle. And we have calculated the value of exterior angle 15. So now number of sides becomes equal to 360 divided by 15. And n comes out to be equal to 24. So 24 is the number of sides of a regular polygon whose interior angle is 165. So in this method, first we have calculated the exterior angle and then we have calculated number of sides. For another method is, we can directly apply the formula of interior angles. The sum of interior angles of a polygon, the sum of all interior angles of a polygon is equal to 180 into n minus 2. So this is the formula for the sum of all interior angles of a polygon. And for the regular polygon, each interior angle becomes equal to the sum of all angles divided by n. So this is the value of each interior angle for a regular polygon. And we have given the value of each interior angle, which is 165. So if we solve this equation, we can find out the value of n. So we will take n on the another side and the equation becomes 165n is equal to 180 into n minus 180 into 2 is 360. So in this equation, we will take this 165n on the right hand side of equation and we will shift minus 360 on the left hand side of equation. And equation becomes 360 is equal to 180n and 165n becomes minus 165n and 180 minus 165n becomes equal to 15n and here we have 360. So value of n comes out to be 360 divided by 15, which is equal to 24. So we can calculate the number of sides by two methods if we have given the interior angle. So here we firstly calculated the exterior angle and then calculated number of sides, and in the method 2 we directly apply the formula for the interior angle of the polygon, so which is equal to 180 into n minus 2 divided by n. The next question of the exercise is 5a. Is it possible to have a regular polygon with measure of each exterior angle as 22 degree? So is it possible that can we have a regular polygon whose each exterior angle is equal to 22 degree? We know that number of sides of a regular polygon is equal to 360 divided by the measure of each exterior angle, because sum of all angles for a regular polygon is equal to 360 degree. So if we put the value of exterior angle in this formula, then the number of sides n becomes equal to 360 divided by 22. Here 22 is the exterior angle which is given to us. So if we divide 22 with 360, then we get 16.36 as an answer. So which is not a whole number. So value of n cannot be equal to 16.36. Value of n should be a whole number. That means it is not possible to have a regular polygon whose exterior angle is 22 degree. The second part of the question is, can it be an interior angle of a regular polygon? So can 22 be an interior angle for a regular polygon? So we know that sum of interior angle and exterior angle is always equal to 180 degree. So for any polygon, we know that sum of exterior angle and interior angle is always equal to 180 degree. because exterior angle is always made on the extended side of a polygon, and sum of interior and exterior is always equal to 180 degree. So now if interior angle is 22 degree, then the exterior angle becomes equal to 180 minus interior angle. So that means value of exterior angle comes out to be equal to 158. So now, is it possible to have an exterior angle of 158 degrees for a regular polygon? So we can check it by putting the value in this formula. 360 divided by exterior angle. So now, if we put the value of exterior angle 158 in this formula, then value of n comes out to be equal to 2.27. So which is again not a whole number. So value of n, number of sides of polygon cannot be equal to 2.27. So it is not possible to have a regular polygon whose interior angle is 22 degree. And the last question of the exercise is, what is the minimum interior angle possible for a regular polygon and why? So now we have to find the minimum possible interior angle for a regular polygon. So first of all, we know that sum of all interior angles of a polygon, the formula to find the sum of all interior angles of a polygon is 180 into n minus 2. So this is the formula by which we can find out the sum of all interior angles of a polygon. And when we talk about the polygon, the minimum possible polygon is a triangle, because a polygon has to have 3 sides. Only then it can form a closed figure. So the minimum sides that a polygon can have is 3. That is triangle. Then the polygon can have 4 sides. Then it is known as quadrilateral. Then with 5 sides it is known as pentagon. And with 6 sides it is known as hexagon, and so on. So we know the formula to find the sum of all interior angles of a polygon, which is 180 into n minus 2, and where n is the number of sides of a polygon. So if we find out the sum of all interior angles of a triangle, we will put the value of n 3 over here, and 3 minus 2 is 1. So the sum becomes 180 into 1. That means 180. So sum of all interior angles of triangle is 180 degree. That means sum of 3 angles is 180 degree. Then for a quadrilateral, the sum of all interior angles is equal to, we will put the value of n 4 in this formula. So for quadrilateral, the value of sum of all interior angles becomes 4 minus 2 is 2. So the sum becomes 180 into 2, which is 360. So the sum of all interior angles of a quadrilateral are 360. Similarly, for the pentagon, value of n is 5. So here what do we get? 5 minus 2 is 3. So 180 into 3 is 540. So sum of all interior angles of pentagon is 540. And then for the hexagon, sum of all interior angles is equal to 180 into 4, because the value of sides for the hexagon is 6. So here we will put the value of n is equal to 6. So sum of all interior angles comes out to be equal to 720. So this is the sum of all interior angles for the polygons. Now if the polygons are regular polygons, so we have asked in the question that polygon is a regular polygon. What is a regular polygon? The polygon is regular polygon if all the sides and all the angles of polygon are same. So now for these polygons, if all the angles are same, then each angle becomes equal to, for the triangle, if sum of all interior angle is 180 and all the angles are same, then the value for the each angle becomes equal to 60 degree. So each angle of the triangle, of the equilateral triangle, is 60 degree. Now for the regular quadrilateral, which is a square, so each angle is equal to 360 divided by 4, which is equal to 90 degree. So each angle of quadrilateral is 90 degree. Now for the regular pentagon, each angle is equal to 540 divided by 5, which is equal to 108. So each angle of the regular pentagon is equal to 108 degree. And similarly for the hexagon, each interior angle for the regular hexagon is equal to 120 degree. So we can clearly see that as number of sides increase, the interior angle also increases. So the minimum angle is of a triangle. So the minimum possible angle for regular polygon is 60 degree. So answer to this question is minimum possible angle is 60 degree, which is of triangle, because a polygon can have minimum 3 sides which are of a triangle. So minimum possible interior angle is 60 degree. The second part of the question number 6 is, what is the maximum exterior angle possible for a regular polygon? So now we are asked that what is maximum exterior angle possible for a regular polygon. So now for the polygon, we know that sum of all exterior angles is equal to 360 degree. For any polygon, the sum of all exterior angles is always equal to 360 degree. So now, if the polygon is a regular polygon, that means all the exterior angles are same. Then in case of triangle, if all the exterior angles are same, then each exterior angle becomes equal to 360 divided by n, where n is the number of sides. So now for a triangle, when number of sides are 3, then each exterior angle becomes equal to 360 divided by 3. That means 120 degree. And for the quadrilateral, when there are 4 sides, then each exterior angle becomes equal to 360 divided by 4, which is equal to 90 degree. And now in the case of pentagon, when there are 5 number of sides, then the each exterior angle becomes equal to 72 degree. So here, the each exterior angle of a triangle is 120 degree. Each exterior angle of a regular quadrilateral, which is a square, is equal to 90 degree. And each exterior angle of a regular pentagon is equal to 72 degree. So here we can clearly see that exterior angle decreases when number of sides are increased. That means maximum exterior angle is of a triangle. So triangle has a maximum exterior angle which is equal to 120 degree. So the maximum possible exterior angle for a regular polygon is 120 degree, which is of a triangle. So these are the all exercise questions of 3.2. If you have any doubt, you can ask in the comment box. In the next class, we will discuss the kinds of the quadrilaters. If you want to learn with me, subscribe to my channel. See you in the next class.